To graph these, we all know that exponentials and logarithms are inverses, right? Because that's what we've been doing when solving. So their graphs are also going to look like inverse functions. Do you guys remember how inverse functions work? What did we say that we did? They reflect over the line y equals x because what's changing? The y's and x interchange with each other. So then my x's in this equation is going to become my y's in this equation because we know that 2 to the x is the inverse of log base 2, right? Okay, so before we do the logarithm, let's focus on the exponential graph. And I don't want you guys to put this in the calculator to go to the table. I want you guys to figure out where these numbers come from. So then when we graph it, you understand the characteristics. Okay, so let's start with some negative numbers. Okay, so the first negative number is -1. We're going to take -1, put it in for x. So we get 2 to the -1. Think back, guys. What does a negative exponent do to something? Huh?
I got sparkling water in my car.
I'm dead.
What do you mean move down? Not transformations. Like, what does this equal? What does a negative exponent mean? We just did exponent properties not that long ago. It means reciprocate. It means that it should go to the bottom of the fraction and make it positive. That's what a negative exponent does. When we saw negative exponents, when we were simplifying this stuff, remember you would always go, cross it off, and put it on the other side of the fraction? That's what negatives mean. It means that it becomes the reciprocal. So I put it here at the bottom, and 1 over 2 to the first power is the same as 1/2. So for -1, our y value is 1/2. Now instead of me getting positive, I want to continue going to the negatives. My question is, what happens as x goes to negative infinity? That's what I'm asking myself right now. So let's try -2. I'm going to go plug in a -2 here. Well, what would that look like? Again, the negative exponent means it reciprocates, so it's going to be 1 over 2 squared, which is the same as 1 over 4. So what happened? As x got more negative, it went from 1/2 to 1/4. Did it get bigger or smaller? Smaller. Okay, now let's go -3. We're going to keep going in the negatives. Well, then that means 1 over 2 cubed, which is the same as 1 over 8. So you get bigger or smaller? 1/8 is bigger than 1/4? Hello? 1/8. Is it bigger or smaller than 1/4? It's smaller. You take 1/8 of something, it's smaller. What about 2 to the -4? What do you think is going to happen? It's going to get even more smaller. It's going to be 1 over 16. So what happens as x goes to negative infinity? If I keep following this pattern, my numbers are going to keep getting smaller and smaller and smaller. But what are they approaching? Will I ever equal a negative? What are you approaching as this gets smaller and smaller and smaller? You're approaching 0. So as x goes to negative infinity, your y approaches 0. Keep that in mind. So now let's plug in the 0. What happens when we get 2 to the 0 power? Do we remember what that is?
1.
It's 1. Because it means that it canceled itself out. Remember 2 to the 1? It divided itself out to equal 1. That's what the 0 power means. Anything to the 0 is 1. What about 2 to the first? Y'all should know these now.
2.
That's 2. What about 2 squared?
4.
2 cubed. So what happens as x gets bigger?
Y gets bigger.
The y gets bigger. Is the y ever going to stop getting bigger?
When x stops.
Will it stop? It goes to infinity. So then my y values are going to keep getting bigger and bigger and bigger. Will they ever stop? They're going to keep going and getting to infinity. Okay, let's graph this and predict what happens. We got -1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8. Notice as they're going to the right, what are they doing? Getting bigger and bigger and bigger. They're going up to infinity. As x's are going to the left, what do we say was happening? The more negative we went. They were approaching 0. So I'm going to extend this line to approach 0, but will I cross it? No. Do you remember what that's called? What? An asymptote. Very good. So we have an asymptote right here. What equation represents that asymptote? Yep. Y equals 0. Because your y values will never be 0. They just approach 0. Okay, I want you guys to take a moment and try and fill in this following part right here. The domain, the range, the intercepts, and the asymptote, which we already talked about. Try filling in this on your own based off the graph that we have.
You really never know if I'm going to you have time. It's not for sure yet. I just wanted to try just in case I don't have anything to do. So I took it today. I need the same score as the last time. So I'm at 545.
Bless you.
Uh, 345. 345. I need a 350. Yeah.
Bro, I got this. I got 42.
It's whack, right? Yeah.
So Grant also was saying the same thing, that he would miss it by a question. It's like all of you guys are right there.
Yeah, I know. It's because we haven't done this since sophomore year.
Yeah, there's a lot of lower level stuff you haven't touched in a while.
I'll see if I see you.
Okay. What? Oh, I told him it could. I told him it could. Alright, so anybody want to take a whack at the domain and range? What did y'all get for domain? Domain, yeah, because this is what we're graphing right now. We're graphing the exponential, which is b to the x. What base am I using? I'm using a base of 2. So right now we're graphing the parent function with a base of 2. So what was the domain for this parent function? Negative infinity to positive infinity. Why? Because the x's go to the left forever, negative infinity, and the x's will go to the right forever, positive infinity. What about the range? Bracket or parenthesis on the 0? So you can equal 0? You approach 0. So remember, when we say we're approaching, we use a parenthesis. Same thing with infinity. So the range, we will never equal 0. They just get really close to that 0 as they drop. There, you approach that asymptote. Okay, what about x-intercept? If I'm never equaling 0, I never actually touch the x-axis. What's my x-intercept? None. What about y-intercept? Where's the y-intercept on this one? It's a coordinate. 0, 1. Right there, it crosses at 0, 1. Every parent function, regardless of the base, will be at 0, 1, because anything into the 0 power is 1 all the time. Okay, asymptote we already talked about. We said the asymptote was at y equals 0. All right, so question on the exponential function. How to find domain and range, intercepts, and asymptote. Okay, so now let's do the inverse. Now, without plugging it in our calculator, we're going to do the inverse based off the table that we just created. You guys told me earlier that inverse functions interchange their y's with x's. So I took my x's and they became my y's. So then now my y's here are going to become my x's. So let's go fill it in. This should be a half. 1, 2, 4, 8. Now I have a question. Were we ever getting negative values as an output for exponential? No, because what happened when we plugged in negative numbers? It didn't give you a negative, it gave you a what? It gave you a fraction. So we didn't get any negative numbers at all when we were plugging in all the x's. So then if I wasn't going to get any negatives for my y's, should I have any negatives here for my x's? No, because it's the inverse. It wouldn't exist then. And to prove that, let's go plug it in our calculator, and you'll see that your calculator is going to say error. So we'll do log base 2. Whoa. Give me a negative number.
7,000.
Error. Not a real answer. Okay, what about 0? 0 is not negative. Was 0 an output that we could get here? Did we ever equal 0? No, we said what? It got closer and closer to 0 as we got negative, right? But we would never actually equal 0. So is 0 going to exist for the log? Let's try it. Log base 2 of 0. Nope. So then we know that we can't have any negative values for logarithm. So then let's plot this one. I'm going to use a different color so you can see the difference. We got 1/2, -1. That's right here. We got 1, 0, 2, 1, 4, 2, 8, 3. So you can tell that as x's get bigger, they go up. But what happens as the x's get smaller? We already said that they can't be negative. So what's happening as I go down? What is it approaching? The 0. It's approaching the y-axis. So can you think of a smaller number than 1/2? But still not in between 0 and 1/2. A 4th, right? So let's try 4th. Let's see where that lands up. That's at -2, so it drops down even further, -2. And then what's going to happen with another number? Let's do 1/16. Oh look, that's at -4. So what is it doing as you get closer to 0? As your x's are getting closer to 0, what are the y's doing? They're getting larger, but in the negative direction, right? They keep going down and down. So that's where we see this asymptote right here. Thank you. Sally, it's for you. So what equation represents this asymptote? What equation represents that asymptote for the logarithm? X equals 0. All right, so what about the domain for logarithm? Is the domain all real numbers? Does the blue line go to the left and right for forever? How far to the left will the blue line go? 0. So it starts at around 0, but we can't get to 0 because remember it said error. So it approaches 0. How far to the right will it go? To infinity. So the domain is from 0 to infinity. What about the range? How far down will it go? Negative infinity. And then how far up? Positive infinity. So stare at the domain and range for a bit. What do you notice about these? They're flipped because they're inverses. The domain becomes the range becomes the domain. X's switch with y's, y's switch with x's. Okay, same thing with the intercepts. Look what happens. The x-intercept does exist on this one because it's at 1, 0. Notice how the y-intercept switched positions and it became the x-intercept. And then my y-intercept, do I have one? Is it going to cross the y-axis? No, because I have the asymptote. So those are also related. And then the asymptote is also related, but instead of it being y equals 0, it's x equals 0. Everything is backwards. All right, so questions on the characteristics of the parents. These are just parent functions. All right, so if you notice right here at the equation that I wrote, I put log base b of x. The reason why there's a b is because the parent function can have whatever base is provided. What base was I using? 2. Now I could have used a 3 and it would have been the same thing as what we have right here. These would have still been the same characteristics. It can be whatever base. So when y'all look down here, we've done transformations all year long. A, H, and K, right? So if you look down here, I have the logarithm with the base b, and I have the exponential with the base b. Those are the parents. The a is not part of the parent function. A is attached, being multiplied. You'll see it. And then h is with the x in the inside, with the x in the inside. And then the k is on the outside. The k is on the outside. The base can be whatever, though. Right? So let's go through the transformations. What happens if we have an h value? If h is positive, we should all know this. What happens when h is positive? What transformation does it change? It goes right and left because it's horizontal, right? Because it's affecting the x value. So we know it goes right and left, but what did I say if it's changing x? Is x by itself? So we always do what for h? The opposite. So if it says it's a positive, that means we're going to move to the left. So if it's at positive h, we translate left. If it's a negative h, you're going to translate right. Yes, this one's the one that's opposite. Okay, what about the k value? K is what's on the outside of the function. So if you add or subtract to the output, what does it do? Up or down. So if k is positive, it's going to move you up. If k is negative, it's going to shift down. That one's not opposite because we don't have to solve for y. Y is already by itself. You don't do the opposite of the k. Okay, then the last transformation is with the a value. We have 3 different things that your a can tell you, starting with just the sign. If a is a negative, what does that do? You went from being positive to being negative. What does that do to the graph? Think about it. All of these values are all positive, right? And then I make them negative. What does it do? Reflects. There you go. So if a is negative, it causes a reflection. What if a is bigger than 1? So when I multiply your height by something bigger than 1, what does it do to you? Stretches you. And then if you multiply by a number between 0 and 1, like a fraction, if you take a half of somebody, what does it do to you? Compress. So these are the same characteristics we've talked about all year. It's just we're talking about them with respect to the exponentials and logs now. All right. So we get out at, let me see, 27, right? Yeah. All right. So we're going to go ahead and graph one more and follow these characteristics. But we're going to graph one that's transformed. Let me go grab it. I thought I had one. I got your other page. We'll only do one. Yeah. Give me for how do we get back?
You want to go or not?
Where you guys going? Can I come too?
No.
Dang it.
Huh. All right, so on this page, I wanted us to graph each of these, but we're not going to do all of them today. And then we want to analyze each of these characteristics that we talked about. So the asymptotes, the domain and range, and the intercepts, the transformations. All right, pick any of them. 1 through 9, pick one.
One.
Boring. Really, 1? Put my ice cream down.
Just finish it. You're almost done.
It's fine.
It's gonna melt and you're gonna be like, dang, I wish I finished it.
I'll just drink it. Did y'all say 2 or 3?
7.
3. All right. So let's do number 3. So right now, just by looking at the equation, what can I figure out? Just by looking at the equations. What? Say it. What'd you say, Sebastian?
Oh.
I think you were correct. I just didn't know what you said. He has go.
studied that.
Okay, you can do your transformations. What's the parent function of number 3? Think back what we just did. We said the parent function can have whatever as its base, like this, right? That's the parent function. And this is the transformation form. So what's the parent function of this one? Y equals what? With no transformations, what's the parent? I guess we'll sit here in silence until someone figures it out.
I'm tired.
Again, look at this one. We said the parent function is just the base to the power of x. Just the base to the power of x. The transform function has the a in front, the h with your exponent, and the k on the outside. So the parent is just the base to the x power. What is the parent of this? 3 to the x power. That's the parent, which means all those other numbers are transformations. What's your a value? What's your a? 1/2. So what does 1/2 do to the parent? What happens if I multiply the parent by 1/2? Please look at your notes. It compresses. If you take 1/2 of something, it compresses. Okay, what about the -1 in the exponent? That's changing what letter? What is it next to? It's next to your x, so that's your h value. What does the -1 do then? Translates where? Right 1. And then finally the -4, that's outside the x. That's your k value. So what happens if you subtract 4 from everything? Shifts down 4. There you go. You listed your transformations. It did not reflect. Why?
Because it wasn't a thing.
Very good. So let's go graph it. Flip it over. 1/2, 3 to the x -1 -4. Okay, go ahead and plug it into your calculator. And we'll get our coordinates to graph. So 1/2, put it in parentheses, times 3 to the power of x -1. Make sure you hit the right arrow to get down from your exponent, -4. Have it plugged in? You're lying because I didn't see some of you even touch your calculator. James Lester. For someone that doesn't like to use calculators. Okay, so hit graph to get a sneak preview. This is what it should look like. It's an exponential. So what do you notice about that asymptote? Is the asymptote still at y equals 0? No, what happened to that asymptote? It went down how many? 4, because we said that it shifted down 4. So it might help you guys to go and graph that asymptote right away. You know that it got shifted down 4, so you know that that asymptote's going to be right there at -4. Okay? And that would be a good key point to go look at when you get to your table. Go to your table. See how they approach 4 pretty much? Now they say -4, but do those actually equal -4?
No.
Remember what I said, it will say -4 because of how close it is to -4. Okay, so the very first one that we can start graphing. Start plotting some. Give me some numbers. 3 what? 3.5. Okay, we should probably get some negatives in there. What about 2, -2.5? And then probably a little bit closer. 1, -3.5. See how it's approaching the asymptote? And then you get even closer. -2, -3.9. So basically at -2, you're really close to -4. So right there is where it starts approaching it really closely. So then as I go up, then we're at 4, 9.5. Way up there. There it is. Now connect the dots. We know as we go up, it goes to infinity. As we go down, it's approaching -4. You graphed it. Questions on how to graph an exponential? All right, so if I do domain, what's my domain right now? How far to the left will the x's go? In negative infinity. How far to the right? Positive infinity. So the domain for these are always... What about the range? How far down did it go? It went to -4, it approached -4, and then how far up does it go? Infinity. So my range would be -4 to infinity. Okay, the last thing, asymptote. What did we say the asymptote was? It was what y value? What were you approaching? -4. Did you have an x-intercept? Look at your graph. Did it have an x-intercept? You sure? It never crossed it?
3 something.
It did cross it. So let's estimate what that is.
2.0.
2.9, something like that. And then y-intercept? -3.7. Okay, so 0, -3.7. Alright, there you go. So tomorrow what we're going to do is we're going to practice graphing all of these just like that. Analyze characteristics.